So if we want to do this model in continuous time, it's very similar actually. Equation 1 is the same. It's just k of t, because k is now just a function of t, right? That's in a continuous time world. K of t equals d of r of t. Right? Everybody agrees with that. That's just saying the amount we have is just the amount people demand at the current rental price. Number 2 is very similar to what we had before. P of t equals the integral from t to infinity. So we're going to integrate future rents. We're going to discount at e to the minus r plus delta tau minus t, r of tau d tau. That is, today's capital price is just the present value of future rents discounted at r plus delta, just like we had before. That is the same formula we had. It's just once you're exponential, you're just adding them together rather than getting 1 minus delta over 1 plus r. Same notion. Number 3, exact same equation we just had. I of t equals I of p of t. And for k dot of t equals minus delta k of t plus I of t. So those are my 4 equations, okay? They look very much like the equations I had, right? There's not much difference, okay? And remember that other equation I had, the other version of this equation? That equation is r of t equals r plus delta p of t minus p dot of t. Okay, let me call that equation 2 prime. That is, r of t, the rental price at date t, is interest and depreciation on the capital price minus this reevaluation term, minus p dot. Right? Which is the same thing we had before. The higher the price, faster the price is going up, the lower the effective rental rate is for a given price. Okay? Now, one thing you want to keep in mind, and this actually is going to turn out to be critical in a minute, is this equation here. People often think of this as like a primitive. It really isn't. This equation, how do you get this equation? How do you get this equation from this equation? Does anybody know? How would you take this equation and get that one? Just differentiate. Remember, this equation holds for all t. This is one of those equations we talked about before. This equation is true at all t, so I could differentiate both sides. Right? That is, if two functions are always equal, then their derivatives have to always be equal, right? They can't be equal they can't stay equal if their derivatives aren't equal. So you could differentiate this with respect to t. But if I differentiate this with respect to t and say, well, this function being equal to this function is equivalent to the derivative of this function being equal to the derivative of that function, that's not true. They're not equivalent. That is, this equation implies this one, but this one doesn't tell you that one. There's a boundary. We threw away a boundary condition when we replaced 2 with 2 prime. Right? We threw away a boundary condition. So if economics determined a unique solution to these equations, and I replace 2 with 2 prime, I'm no longer going to get a unique solution. Not because there really are other solutions to this original problem, but because I've left something out. But you understand that? We're going to get a bunch of solutions that aren't really solutions to the problem we're interested in. Because we threw away one of the restrictions that our model implies. And in particular, what we threw away is the restrictions that prices are at the right level. Right? That's the important restriction we threw out. Right? That's a critical way to think about this model. If I'm only going to impose this, and this, then I threw away one of the most fundamental restrictions economics opposes, which is the level of prices has to be set at the right level. Otherwise, you ain't going to have an equilibrium. Right? People understand that? It's not like I'm bringing in some esoteric, crazy condition that I made up and mathematicians thought up or whatever. It has nothing to do with that. It's that there's this restriction that the level of prices has to be correct. I've just ignored. I've just said, okay, fine. I'm not going to worry about that for now. Well, you're going to ultimately have to worry about it, okay?